Welcome to the Understanding Data Lesson Summary video. Data is the foundation of data science. To be a successful data scientist, you must understand data in different forms, whether structured, semi-structured, or unstructured. In the videos and readings in this lesson, you explored how data can be generated, stored, and accessed. For data to be useful, it must be interpreted to derive meaning. Structured data has a well-defined structure or adheres to a specified data model. Can be stored in well-defined schemas such as databases, and in many cases, can be represented in multiple tables with rows and columns. The schema defines the relationship between the tables. Semi-structured has some organizational properties, but lacks a fixed or rigid schema. It cannot be stored in rows and columns. It contains tags and elements or metadata, which is used to organize data in hierarchy. The metadata provides useful information about this data. Metadata can be categorized as technical, process, or business. Metadata also needs managing to ensure information access and integration from various sources and appropriately shared across an organization, usually in a data catalog. A well-implemented data catalog enhances data discovery, repeatability, governance, and access. Unstructured data is heterogeneous. It comes from a broad range of sources and has a variety of business intelligence and analytics applications. Analyzing unstructured data often requires artificial intelligence to gain insights from it. It is important to know that the data for analysis can be stored from anything with an electronic footprint, whether it's generated and stored automatically or through manual efforts. While older records may exist in analog formats like paper, they typically require conversion to electronic formats for effective mining and processing. Typically, organizations use internal applications to support their day-to-day management of business activities and workflows. You can use data stored in databases and data warehouses as a source for analysis. You can also find publicly and privately held datasets for analysis. You can even purchase proprietary datasets. These datasets are usually made available as a single flat file such as CSV format or spreadsheets. For a number of years, flat files stored information about their structure in a format called XML. More recently, you see text data exchanged in JSON format, a straightforward format readable by humans and machines. JSON data does not have a predefined schema, so you can easily transfer it between data structures as they evolve. You can usually access the data in modern cloud-based software applications through an application programming interface or API. When dealing with JSON data, applications use what is called a RESTful API for data transfer. Many data providers and websites provide APIs for accessing their data. Twitter and Facebook both provide APIs to source data from posts for performing tasks such as opinion mining. This allows you to analyze sentiments on a given subject, such as customer satisfaction. Usually, data gathering and management are typically assigned to data engineers, although, as a data scientist, you most often need to transfer data for analysis. This process demands flexibility. As a data scientist, you will frequently work with extensive data sets, sometimes reaching terabytes in size. These continually updating massive data sets stem from sources like IoT applications, sensor data, and the constant influx of social media data collected from millions of users. Data scientists have a unique relationship with data. You specialize in data, so you must understand it intimately. But before you can analyze it, you'll need to know the modern-day ecosystem for organizing, storing, manipulating, and retrieving data. This lesson introduced you to some of these ideas.